Next chapter is optics of low vision aids. What is low vision aids? They are devices, magnifying devices, also known as angular magnification. The basis is angular magnification. Low vision aids are magnifying devices which are designed to be used as reading aids. So mostly they are used for reading, and most of them for near vision. Also some of them are used for distance vision. All the low vision aids, they work by presenting the patient with a magnified view of the object. Most are optical systems which act by increasing the angle subtended by the object at the eye, thus producing an enlarged retinal image. The magnifying power of such an optical system can be defined as retinal image size with the use of instrument divided by retinal image size without the use of the instrument. Projecting systems, they are also coming into use as low vision aids. An enlarged image of the object is presented to the patient on a screen which he or she can view from a convenient distance. Closed circuit television is one means of achieving this and is in limited use. And there is the convex lens. The convex lens, when the object is located between the first principal focus and the lens, an erect magnified virtual image is produced which is viewed by the eye. As the object moves near the first principal focus f1, the virtual image becomes larger and is situated further away from the eye. So this handheld magnifier can be positioned by the user so that the image is formed at a comfortable viewing distance from the eye. The stand magnifiers are made so that the optimum object lens distance is maintained. The field of vision, which is obtained with a convex lens used as a hand or stand magnifier, is dependent on the size or aperture of the lens and on the eye and lens distance. The greater the eye and lens distance, the smaller will be the field of vision. A convex lens is used in different forms. It may be used as a handheld magnifier. The standard loop is multiply 8 times is equal to 32 diopter. It can be positioned by the user so that the image is formed at a comfortable viewing distance from the eye. Convex lens can be also used as stand magnifiers. The optimum object lens distance in this case is maintained. Third form is a paperweight. It is very thick, plano-convex, and it rests on the page. It is a convex cylindrical reading aid. It is a bar-shaped lens. It has no refractive power or only a low converging power in its long axis, and has a high converging power in cross section. It is laid on a line of print, like for example here, produces vertical magnification of the letters. Now telescopes are used to achieve magnification at distance. At near we use convex lens. At distance we use telescopes. During a low vision examination we use two types of telescopes, which are two types are Keplerian, also known as astronomical, and Galilean, which is also known as terrestrial. Now both telescope designs are considered afocal because parallel light enters and exits the telescopes, produces angular magnification. In the Galilean type, the rays do not cross, but they do cross in the Keplerian. So this means that the image is erect and virtual in the Galilean system, and inverted and real in the Keplerian system. In Galilean, the rays do not cross, so the image is erect and virtual. And Keplerian, the rays cross, so the image is inverted and real. So in the Keplerian, the image is inverted, so it requires a re-inverting prism, which is placed between the ocular and the objective, so that the images do not appear upside down and backward through the telescope. So the Galilean system, it is composed of convex objective, this is convex objective, and concave eyepiece, separated by the difference of their focal length. So this is the separation, which is the difference of their focal length. So this is the focal length of the objective, and this is the focal length of the ocular, and the difference is the separation between the objective and the ocular. It produces erect, magnified, and virtual image. Erect, this is erect image, magnified, virtual image, not greatly distorted by curvature of field or astigmatism. So this is erect and virtual image. It is compact and usually mounted on in a spectacle frame. It can be adopted for viewing near or distant objects, but it is difficult to combine near and distance use in the same instrument. Magnification produced by this Galilean system is Fe divided by Fo. Fe is the eyepiece length. Fe is the power of eyepiece in diopter, while Fo is the power of the objective. Power of eyepiece divided by power of objective. The practical usefulness of the optical magnifying devices as low vision aids is limited by these factors. Increased magnification cause decreased field of view, cause rapid scanning of a line or page of print impossible. The object lens distance is critical. The object to be viewed has to be held close to the eye. Magnification causes decreased depth of focus and decreased depth of field. There is inverting prism in Keplerian telescope, which increase the weight of the telescope compared to its Galilean counterpart. But the optical quality of Keplerian telescope is far superior to that of the Galilean telescope. Therefore, in clinical practice, we use Keplerian telescope if the magnification needed is 4 times or greater. Keplerian telescope consists of a plus power ocular lens and a plus power objective lens. It has a large field of view at a given level of magnification. Tube length is longer, more expensive, available up to 10x. These are the Keplerian telescopes. You can see the tube length is longer. These are also the Keplerian telescopes. These are more Keplerian telescopes. Galilean telescope minus ocular and plus objective. So the objective is plus in both, but here the ocular is minus, and Keplerian the ocular is also plus. Smaller field of view at a given level of magnification, smaller and lighter, less expensive, available up to 4x. This is a Galilean telescope mounted on spectacles. This is again Galilean telescope mounted on spectacles. This is a telescope comparison. Objective in both are positive, but ocular in Galilean is negative. Galilean is a simple lens system. It is lighter, the lens is shorter, the exact pupil location is inside system, the magnification is low, effect of focusing for uncorrect myope, so there will be decreased magnification. Effect of focusing power and uncorrected hyperope, there will be increased magnification, field of view smaller, image quality poorer, and cost is low. So in myopes there is less magnification with Galilian and greater magnification with Kepler. In hyperopes, more magnification with Galilian. These are handheld magnifiers. These are also handheld magnifiers, convex lenses. These are also handheld magnifiers. These are stand magnifiers. These are also stand magnifiers. These are also stand magnifiers. Again the stand magnifiers. Again the stand magnifiers. CCTV is the most common device. It has both projection magnification, relative distance magnification, contrast, distance. But they are difficult to calculate the magnification because must have a reference distance. Therefore, we work in diopters.